Take a look at this image. Take a guess. Is it drawn by a person or drawn by a computer? Now, take a look at this second image. Is it drawn by a person or drawn by a computer? If your answers to these questions are computer, specifically a GPU, well, you're correct. It is drawn by a computer and not a person. This is Stable Diffusion. Let's talk about tech. Stable Diffusion is a deep learning text-to-image model released in 2022. It is primarily used to generate detailed images conditioned on text descriptions, though it can be used to other tasks such as in painting, outpainting, and generating image-to-image translations via or guided with a text prompt. So it was developed by Runaway, CompVis, and Stability AI, but now it's now being maintained by Stability AI themselves. It was initially released on August 22, 2022, and the stable model is version 2.1. That is only the base model. There are too many Stable Diffusion models, but that is the base model, the Stable Diffusion 2.1, and it was released on December 7, 2022. It runs on Python programming language, one of the most popular programming language today. And it is powered by NVIDIA CUDA, AMD ROCm, or DirectML if you're using Windows. Actually, operating system supported on Stable Diffusion is it's vast because you can run this on Windows via CUDA or DirectML. You can run this on Linux via CUDA and or AMD ROCm, and on Mac. Yeah. You can run also this on your Macintosh systems. And unlike DALL-E and Midjourney, Stable Diffusion is open source. Yes, you can freely use it anytime you want. So just like I said earlier, Stable Diffusion is open source. So its code and model weights have been released publicly. And it can run on most consumer hardware equipped with a modest GPU with at least 8GB of VRAM. Well, yeah, 8GB of VRAM. Well, actually, you could run this on lower VRAM hardware. I have a 1050 Ti here. I tried it and I could still generate, although a little bit slow because it's 1050 Ti. What could you expect with 768 CUDA cores? Right now, CUDA cores in RTX 40 series, 30 series are thousands of 3,000 plus CUDA cores, so it's definitely faster there. So let me know if you tried Stable Diffusion on those GPUs. And also, I haven't tried using Stable Diffusion on AMD GPUs because first of all, I don't have an AMD GPU to begin with. And I could try this on DirectML, but still, I have an NVIDIA GPU, so I run this on native CUDA, not DirectML. But yeah, you could run this on 4GB of VRAM with the right settings, of course. I will demonstrate how Stable Diffusion works later in this video. Well, can you run this on Intel Arc GPUs? The answer is definitely. With DirectML. At least on my web UI that I'm using right now. Because OpenVINO is not yet supported on the web UI that I'm using. But Intel created a video demonstrating Intel Arc GPU is going to generate an artwork with Stable Diffusion in GIMP. I would link down the video in the description below in order for you to check it out later after this video. And in conclusion, you could run this on Intel Arc GPUs with DirectML on this particular web UI that I'm using, or in GIMP with OpenVINO. So yes, you can. Okay, now I'm going to demonstrate how Stable Diffusion works and what is it all about, right? And what is this web UI that I'm using? Actually, Stable Diffusion originally is a command line interface program. There's no GUI until this web UI that was created by Automatic 1111. That is his GitHub username. So yeah, it's Automatic 1111. That is the Stable Diffusion web UI that I'm using right now, and it has support for CUDA, AMD ROCm if you're using Linux, and DirectML if you're using Windows. So right now I'm okay. Let me transition a little bit. Okay, so here we go. Here's my desktop right now, and here we go. This is the command line interface, but if you go here on the local URL, okay, this is how it works. So here we go. We have text to image, image to image, and some extras here, and some PNG info. But this is the real deal. Text to image. This is how Stable Diffusion, the foundation of Stable Diffusion. Okay, so all right. So let's take a look at the task manager. By the way, I'm using anything version 5 Inc. This is one of the nice anime Stable Diffusion checkpoints or models, and I have I have the Stable Diffusion 2.1 as well. This is the base model, and for some reason they recommended the safe tensors instead of the CKPT file for security purposes. But I'm doing this locally and it's not connected to the internet, so it's okay. But I downloaded the safe tensor variation of it. Alright. Now, so like I said earlier, I could run this on 4 gigabytes of VRAM. So like I look at this. Yes, it's almost full. If you have resizable bar, well, you could turn on resizable bar if you have a supported GPU, and then if your dedicated GPU memory is already packed full, it will spill over to the system memory, which is the RAM. I have a 32 gigabyte of RAM, but I don't have resizable bar to begin with because this is an old motherboard and it's not supported, but it supports above 4G decoding, so you need to turn that on if you want to. It helps. So alright, so my VRAM is packed full, but still I could still generate drawings, and I will show you later in this video. Alright, so let's take a look at this. I have a notepad here, which is a prompts, the list of prompts. So what are those? What are those prompts? So what are these low-res bad anatomy, bad hands, text error, missing fingers? Well, it belongs to the negative prompt, because negative prompt basically is what what you don't want to generate. For example, bad anatomy, bad hands, missing fingers, worse quality, low quality. So you don't want that, right? So you input that prompt in, you know, in negative prompt, if you will. So, all right. But what about I'm going to generate? You input you want to generate in this one, in this text box here, which is the prompt or the positive prompt, if you will. So I'm going to use a LoRa or low rank adaptation. A low rank adaptation is it looks like an extension which is extends the capability of your stable diffusion model. For example, I'm going to use a March 7th LoRa right now, and we will see how is it working. All right, so I'm going to use a March 7th LoRa. So I have two LoRas installed here. I have a March 7th one and a Silverwolf one. But let's test March 7th first. So what you're gonna do here is paste this prompt here and then click your LoRa. So I'm going to demonstrate here. So here's my prompt. Let's copy this prompt here. But without LoRa, this will not generate March 7th. It will generate a generic anime girl. Yes. But with LoRa, you could generate the exact copy of March 7th. So yeah. Let's choose the LoRa, March 7th. And then let's modify the weight. So weight is something how what do you call this? How pronounce the asset. I'm sorry if I'm not explaining it so much because I'm still trying out this technology. Actually, I've been trying this technology for days now, and I'm still mastering those syntaxes. But yeah, it is what it is. So let's, according to the LoRa author or the developer of the LoRa, the best result is from 0.6 of weight to 0.8 of weight. So we need to set this to, I think, let's set this to, let's go to the upper limit, 0.8. So there you go. We have a LoRa March 7.8. And then let's adjust our resolution to 568. To 512 by 768. Let's try simpler sampling methods. Yes, there are too many sampling methods. I don't know what are the difference here. So if you know what are the different sampling methods in Stable Diffusion, if you're an expert on this, help me or help the others by commenting down below. It's many sampling methods to begin with, but the most popular ones are Euler A, Euler, and DPM++ 2M Caras. And the most heavy I think here is the DDIM. So yeah, that's it. Those are the sampling methods. Again, if you know the difference of those sampling methods, if you're expert at Stable Diffusion, let me know in the comments below. Help me. Alright, so we're going to have a drawing of March 7th here. Let's use Euler A with sampling steps of let's use 28. There you go, 28 sampling steps. So it will sample 28 times. this prompt will sample in 28 times. So that is sampling steps to you. And then the CFG scale, I'm still confused on what this parameter do. So I'm just going for 11 because some other stable diffusion artist uses 11 CFG scale and sampling steps of 20, but I want to increase it on 28. And then we're gonna use a Euler A with a LoRa of March 7th with weight of 0.8, and we have this prompt to trigger the LoRa. And then let's bring out the task manager, and then let's generate the image. I'm going to speed up this on editing, but you will get the point here. So let's generate now. Okay, right now we are 14%. Disregard this. This is the most accurate one. The command prompt. So we're now in 18%, and already 5 samples are already processed. There you go. 6 samples are now being processed. And look at my GPU right now, and also my CPU. Yes, it's 7th gen. And I'm using Windows 11. I know it's unsupported, but Microsoft not gonna stop me. Okay. Let's go back to the GPU, and we're still using about 48% of our RAM. It's good. Actually, when I'm using a large language model, it's more RAM intensive. But there you go, we have the image now. It's almost there. So this is stable diffusion. All right. So what am I talking? There you go. It's much more memory intensive in large language model than stable diffusion models. So if I'm using a large language model like Pygmalion, which is I'm going to create a Let's Talk About Tech video about it soon. It goes up to 24 gigabytes of RAM, but here in stable diffusion, but still, I'm still in normal usage because I have 32 gigabytes of RAM. So why not, right? So let's speed it up and let's finish the drawing. Alright, so here we go. This is the final drawing. 28 sampling steps in Euler A with CFG scale of 11 and with LoRa of a LoRa of March 7th in 0.8 weight. This is the final drawing. There. See? how technology evolved right now. We have March 7th here, but it's quite blurry. So again, it's not perfect, but you get the idea. It's kind of blurry actually. Yeah, it's blurry. Yeah, it's kind of blurry, but you get the idea of how stable diffusion works. So you have a prompt you want to generate, and you have a negative prompt that you don't want to generate. And then you select a sampling method. I use Euler A, which but I could do this on more heavier sampling methods. I don't know. Again, I don't know what are the difference of these sampling methods. Again, please let me know in the comments below. I think DDIM is one of the heaviest one. How about let's regenerate this on DDIM and let's compare it with one another. So I'm going to use a sampling method, DDIM sampling method, with sampling steps of same 28 and with a CFG scale of 11. So let's now generate. Oh, again, I didn't modify the parameters or the prompts. We have still Alora. Let's generate. Alright, we are now in total progress of 43%, okay, with 12 samples processed. And we're now seeing an image of March 7th here, but still it's not complete. So I'm going to speed it up again and let's see how the image is being stitched using DDIM sampling. So let's go. So it's now already 100%. It's now finalizing some progress. There you go. We have the image here. Let's maximize for a little bit. There you go. We have March 7th in DDIM sampling. Let's compare this with DDIM March 7th to the Euler A March 7th and see if you can see the difference. Okay, so we are now comparing two March 7th here. They are still the same prompt and same negative prompts, and generated with my GPU, GTX 1050 Ti. So the only main difference here is the sampling method I used, and that's it. Pretty much it. They have the same sampling steps and CFG scale. So again, let me know in the comments if you know what are those parameters. And also, I turned off my camera right now in order for you to see the difference of two March 7ths here. So this March 7th is generated using Euler A sampler, 28 sampling steps and 11 CFG scale, just like I generated earlier. This is the output, and this one is the output of the TDIM sampler. Same sampling steps, 28, and same CFG scale. So, yeah, I think the clear winner here is the DDIM, but let me know in the comments below. What can you see about these two March 7th here? So, right. So that's how Stable Diffusion works. You just input a prompt and a negative prompt, your sampling step, your sampling method, your CFG scale, and you're good to go. How? Wow, technology is evolving. But there's a question. The question is, can you call AI artwork as art? So, I made a poll on X. Yes, that's the new name of Twitter as of recording of this video. So, I created a poll on X last October 17, 2022. Last year. Asking the same question. Can you call AI artwork as art? It had 11 votes because I'm not that popular. But in 11 votes, 36.4% of those votes are yes, and 63.6% of those votes are no. And I think I understand why. I'm going to quote something from Wikipedia, which is this. Visual artists have expressed concern that widespread usage of image synthesis software such as Stable Diffusion may eventually lead to human artists along with photographers, models, cinematographers, and actors gradually losing commercial viability against AI-based competitors. And then it cites this article from MIT Technology Review, and I'm going to quote one thing for sure here. Quote, these open source programs are built by scraping images from the internet, often without permission and proper attribution to artists. As a result, they are raising tricky questions about ethics and copyright. So that's why I understand. I understand artists, human artists, sentiments about AI-generated art. I understand now why they are so angry or somehow upset about it. And with even HoYoLab, in HoYoLab, if you posted an AI art on HoYoLab, people there, or the community, the majority of the community there don't like it. Don't like it at all. So, it makes the question still is, can you call an AI artwork as art? Or AI generated art as art? What is your opinion about this? Let me know in the comments below. What is your opinion regarding AI generated art? Please be constructive and state your opinion respectfully, please. I know this is a controversial topic in technology and art, so yeah. But in my case, it depends on who you ask to, if you're gonna call it an AI art as art or not. And And also, I will prefer a human to draw than a computer because still technology like this, it's still not perfect as human drawing. And that's it for Let's Talk About Tech. I know that this is a interesting technology, but a controversial one. So, again, let me know what are your opinions about this. Again, state your opinions respectfully. And thank you for continue supporting this channel and the series, although it's still episode 2. But yeah, I think we are going for more episodes because I'm going for a large language model called Pygmalion and also the KB Lake architecture from Intel. Supposed to be I'm going to record KB Lake before this one, but this technology is really interesting for me. But again, it's controversial. So I tackle how the technology works and how and why the community is somehow against it or somehow repelling these technologies. So all right. So it's me, it's Tinjan06. This is Let's Talk About Tech. See you on the next one. Necrotron to the next level. Ciao.